All right, today we're going to talk about a topic that is synonymous with building PCs, and that is the idea of future-proofing. Future-proofing is kind of impossible these days. We're going to talk about why. There has been such changing landscape over the last 15 or so years when it comes to PC hardware and technology sets and feature sets. And we're going to explain why the idea of future-proofing is impossible, but things that you can consider when upgrading your system or building a new system or buying a pre-built or whatever to try and be as future-ready as possible. But it's becoming more and more impossible these days. Now, we're not talking about the idea of pricing being the reason why it's impossible. It's because of just the changing dynamic of what PC components are, the way they interact with each other, and feature sets that are making their way in that's kind of being gated behind hardware. So the old problem was, is your hardware going to be fast enough for future games, right? Resolution scaling was something we saw that was kind of like the major future-proofing thing people had to sort of arm against. For instance, the 1080 Ti Pascal series was an absolute beast of a graphics card. Yeah, I forgot we have one behind us right there. So the 1080, that's why it's back there. The 1080 Ti, though, was a beast of a graphics card. It was capable of playing 4K games at its time, like at its era. It wasn't the highest FPS at 4K, but it was capable of it. And when it came to future titles, the card was able to run the game. But what you had to consider with future-proofing was, can your system last a good 5 years, 7 years, or 10 years. 10 years seems to be the real number. A lot of people kind of wait to make a major platform change or upgrade when it comes to their system. And all you had to really worry about was game resolution and the actual difficulty to run a game going to outpace the raw horsepower of your components, whether it be CPU, GPU, or potentially system RAM, DRAM. But the new problem now is the fact that we have feature sets that are coming out that are newer than older hardware that's being gated behind the newest hardware. So what do I mean by that? Specifically DLSS. So if you remember, the 1080 Ti was the last period of the GTX series of graphics cards from NVIDIA. It moved over to RTX because of ray tracing. That's what the R stands for, ray tracing, right? And obviously the RTX graphics cards were able to do real-time ray tracing significantly faster than, CUDA cores could because they were built from the ground up to be accelerators to do one job, ray tracing. Now, there was a lot of uproar of going, why is it behind hardware? Why is it behind a hardware wall? So NVIDIA said, fine. We'll unlock it. Go ahead and run it on your Pascal card and watch what happens. And it was a terrible experience. And it's one of those things where somebody who might have bought a 1080 Ti when it was new thought that they were truly future-proofing their system for maybe 7 years, but the next generation made the obsolescence and really the writing on the wall of where hardware was going really, really obvious. The other thing that the future has really sort of gone towards when it comes to graphics cards is DLSS, or deep learning supersampling. That is another hardware feature set that can't be turned on something like Pascal or older cards because it requires the tensor cores that are built into the GPUs. So that was a perfect example of a major shift in design when it comes to hardware that was impossible to future-proof for. Now, here's the other thing. If you bought a 20 series card or you bought a 30 series card and you were like, okay, I'm probably future-proofed now. How long will it be before they change, the tensor core architectures or the RT core architectures? And obviously the CUDA cores are still around. But now you're starting to see feature sets become locked behind hardware again. Obviously, when it comes to like DLSS 3.0, DLSS 4.0, DLSS 4.5, you'll find that older RT cards that are not more than anywhere between 5 to 6 years old are incapable of running the latest feature sets because, once again, they are locked behind hardware. So when it comes to DLSS, though, it's still not cut and dry. Like, you can't just say, well, Now, when it comes to upscalers like DLSS and FSR, it's still not super cut and dry. Like, you can't just go, well, my card says or DLSS 3 is out, so I'm getting all the DLSS 3 features. And what I mean is, like, if you have an RTX card, you have access to all the upscaler tech as it comes out, but there's other technologies that launch with a major version change. So, for instance, DLSS 1 and DLSS 2 and 3 and 4 and 4.5, if you have an RTX card, you get the upscaler. That's part of the hardware, the tensor cores and all that. But there's other feature sets that can get locked behind there, like we just talked about a moment ago with FrameGen. 30 series cards were the first cards that were truly locked out of a DLSS feature set. Again, I know you guys don't care about FrameGen, but as an example, just hear me out. So 30 series cards don't get FrameGen. 40 series cards had FrameGen 2X, which is just FrameGen on, right? That means every other frame is an AI rendered frame. It's a fake frame. We know how that works. 50 series was the first card now that we saw that locked 40 series out of a feature set in DLSS. For instance, multi-frame gen. So we're talking about 2x, 3x, 4x, and I think there's 5 and 6x now. But you see what I mean? Where there could be future technologies that are locked behind an overall like naming scheme like DLSS, but if you don't have the hardware that supports it, you're locked out of those feature sets. AMD is kind of under fire right now because FSR4 is the first FSR feature set that's actually based on machine learning, where you have to have a 9000 series, so a 9060 to 9070 XT graphics card to actually utilize that and turn it on. And this is from the brand that has been notoriously backwards compatible and doing things via software rather than hardware to make it as widely available to their users. And even people that don't have AMD graphics cards could still run FSR because it was a software-based thing. But now you can't even run FSR4 on an NVIDIA card if you wanted to because of the fact that it's locked to hardware on AMD's side with 9000 series GPUs. But with that said, modders have actually been getting FSR4 to work on older series graphics cards from AMD, 7000 series and whatnot, showing that that's really less of a hardware lockout and more of a policy forced obsolescence of a graphics card for AMD users to try and get them to buy more. But it's an example of hardware gating when it comes to new technology, which is something that is nearly impossible to plan for today. So you're starting to see the ability to be future-proofed more and more difficult because of the fact that it's not just a horsepower bet anymore. It is a horsepower and feature bet on whether or not the features are going to be something that's available to you in the future. Now, you have to ask yourself, are these features that are important to you? Are these features that are absolutely must-haves for you? And if they are, well, now you're stuck in this conundrum. Do you buy the highest-end graphics card that you can personally afford right now to hope that future titles that come out that maybe are relying on feature sets like DLSS is something games heavily rely on today? It's unfortunate that developers have really leaned on the efficiency of DLSS to kind of shortcut some of the optimizations of their own titles. And relying on something like DLSS or even frame gen at this point, which isn't something you should really consider with future-proofing. I think most PC enthusiasts and gamers these days just know frame gen is not a solution. It's not a solution to a horsepower and or an optimization problem. It's a Band-Aid. And I think we could all agree it's not something we should be that excited for, especially when they keep upping the amount of frame gen. Now, if we had frame gen, which was every other frame was alternating a fake frame, essentially AI rendered, and then 2x, and then 3x, and 4x, and now 5x, and I think even 6x or something like that. Nobody is running that and going, look at how good my frames are. Everyone knows it's a terrible Band-Aid. Anyway, I digress. It's an example of a future feature set that, again, is locked behind hardware, where if you had a 30 series graphics card or a 40 series graphics card, you were locked behind 2x or less, right, or off. And then obviously 50 series allowed it to go all the way up to these crazy X numbers that exist now. But DLSS and feature sets like that have become Band-Aids to where games developers are not optimizing as well as they should. Now, that also means if you're on older RTX hardware, let's say you bought a 3090 Ti, an extremely expensive graphics card for its time, although cheap by today's standards, is something that is not going to be capable of running the future versions of DLSS that come out, right? That's already locked, I think, to DLSS 3.0 or older. It can't run 4.0 or 4.5. And so what's happening now is game developers are going to start relying on this new technology that's coming out from the FSR for AMD and DLSS for NVIDIA, because they're sending their engineers to these developers, right, AMD and NVIDIA, to optimize for those feature sets and get them implemented into their games. So what'll start happening is now you're going to feel like you're on a 1080 Ti again because games are going to rely on hardware and features that you're locked out of because they don't physically exist on your card. At least it's the story we're being told. It's still not entirely believing the fact that these are feature sets that are truly locked behind hardware, but that's the story that's being told. Now, when we talk about CPUs, it's the same sort of thing. When it comes to future-proofing, people that adopted maybe, say, Zen 3 architecture or like a 5950 CPU, which was a beast of a CPU on AM4, immediately found themselves at a dead end of a platform. Because if you adopted it then, you adopted it at the end of its life cycle, because remember, Ryzen and AM4 came out back in 2016. So you might have gotten yourself a beast of a system, but you also jumped on the train at the last stop. So now you aren't necessarily future-proofed at that point because you don't have an upgrade path. You have hopefully a high enough CPU that it's going to be relevant when it comes to what games are demanding in the future. Now, when we look at titles like GTA 6 and some of these other future titles that are coming out, it's getting a little scary at how high the horsepower requirements are for your systems these days. And I think people that are still running 3000 series Ryzen, maybe 4000 series Ryzen, are going to start feeling the pinch a little bit when it comes to CPU bottlenecks starting to creep up into these titles that are going to be heavily CPU dependent. As we deal with more open world and sandbox type titles, it becomes really, really apparent that your CPU can quickly become the bottleneck. But I bring up AM4 because what happened right after that? A socket change to AM5, a DDR change to DDR5 being required. And now we're already hearing rumors about AM6. We're hearing rumors about DDR6. We're hearing rumors about PCIe 6, although I'd be surprised if PCIe 6 for graphics and full 16x slots would happen so quickly right on the heels of PCIe 5.0. But what's also happening here when we talk about these major changes when it comes to sockets is the fact that if you have to change the entire platform to adopt the newer technology, then you're definitely not future-proofed at that point, right? The idea of future-proofing, first of all, is a lie. There's no such thing as future-proof. Your system will become obsolete at some point. So let's just go ahead and get rid of the word proof to begin with. I like to call it future-ready as best as possible. Now, Intel, although they are struggling in many ways, kind of did it right, where they had that interim period where the 12th gen, 13th gen, and 14th gen were able to utilize either DDR4 or DDR5, which was kind of nice, giving you a little bit of a buffer period where if you were coming on an older platform and you had DDR4 RAM that you wanted to use, you could throw it into the newer platform, getting the appropriate motherboard, and have more longevity and lifespan to your system. AMD didn't do that. They had a hard cutoff and required DDR5 from the start. And the same thing's going to happen when DDR6 comes out. Now, when that's going to be, given all the RAM stuff going on right now, it probably got pushed out a little bit. But it's the kind of thing you have to consider when we talk about our future-proofing or future-readying our system. Now, here's another trend that we've seen, obviously, over the last 6 years or so, is the incredible increase in power requirements. The only parts of your system that I think you can truly future-proof, and I'm just going to say the word proof, as much as I hate that word because it's simple and we know what we're talking about here, is your power supply in your case. That's about it. And the reason why I say that is even monitors for a while there, to use features like FreeSync and G-Sync and all that, they had requirements to be able to be ready for that technology. So there became a point where even your monitor, which you might have bought that was a super high-end 4K or something like that, right before these technologies came out, well, you're locked out of those techs too because of the fact that your monitor isn't FreeSync ready or G-Sync ready or certified or compatible, whatever you want to call it. But power supply just does one thing. It delivers power. Delivers 12 volt, delivers 5 volt, and 3.3 volts. That's all it does. Whether or not you have the right cables or not for, say, ATX 3.1 or any of that can be remedied by getting an adapter, or plenty of cable companies are making native cables to plug directly into your power supply, even if it's an older type, to convert it to the new cable. So you can kind of be ready hardware-wise like that. But with the increasing demand of the power that these parts are requiring, I mean, we've got 250 to 300 watt CPUs. We've got 600 watt to now 1,000 watt 5090s, which means that an 850 watt power supply just 5 years ago, which might have seemed like more than enough to survive several iterations and upgrades of your system, is now not enough for even something like a 5080 to be comfortable. So you got to start thinking about that now. You got to start building in even more headroom if you're buying a power supply, because you might find yourself, who knows, next gen, having to buy a new power supply because we're seeing these incredible jumps in power. For instance, the 2080 Ti, which was a 250 watt card, kept the same TDP as the 250 watt 1080 Ti. So that jump from one generation to the next meant your power supply was safe. Then we saw the 350 watt 3090. Then we saw the 450 watt 4090. Don't forget, overclockable up to 600 watts because of the cable spec. Now the 5090, if we're talking enthusiast grade hardware, right, now is requiring a 600 watt PCI Express delivery, which means 1200 watt power supply is really the real requirement here for safety. If we saw a 250, then a 350, then a 450, and then a 600 jump from just those few generations, And now we're seeing custom card builders making cards with dual plugs, which we all know should have always been the standard for anything running 450 or more. If that becomes the new norm for the next gen of graphics cards, are they now going to be 800 watts out of the box? Because if you have two of those cables, the graphics card companies are going to say, hey, now we can push the power limit even more. It's a little bit safer. Who knows what the NVIDIA spec is going to be? NVIDIA has clearly endorsed these crazy jumps in hardware power requirements. Your power supply is going to start feeling underspec'd very, very quickly. Doesn't mean you should run out and immediately buy a 1500 watt power supply if you're not an enthusiast buying that level of hardware. But if you even look at like the 80 tier or the 70 tier of graphics cards, we've seen big jumps in power requirement even for those graphics cards, because now a 5070 is pulling the exact same power wattage or power draw as a 2080 Ti was. So that is the writing on the wall of what power demands in the future are going to be. Things like Moore's Law are kind of like, those rules are being bent and broken these days. Right now, we're kind of in this era where it's just give us, and by give us, I mean the engineers are saying all the performance possible, damned be the power draw, just let it be what it is, and let the system, the integrators and the motherboard manufacturers and the graphics card manufacturers build their power delivery systems and their VRMs to handle the power requirements. So we're seeing this crazy scaling of power draw, where a high-end gaming system just 7 years ago would have pulled maybe 600 watts from the wall. We're pulling more than that from the wall just to feed the graphics cards these days. So you can see where it really becomes difficult to try and have the idea of future-proofing. The only reason I'm really telling you this right now isn't to try and doom and gloom you to say, well, future-proofing's dead. I've made this video numerous times over my YouTube career, and the argument has always been the same, that future-proofing is not possible. It's just how long will your PC stay relevant or stay within the requirements of the titles that you want to play and be ready for future titles. That's all it is that you're hoping to do here when you build a quote-unquote future-proof system, is knowing that you can play titles well into the future without being forced to upgrade your system. Remember, being forced to upgrade your system is truly what makes you not future-ready. And not all of these titles and these future technologies are something that you have to run. I think DLSS is one that if you haven't experienced, you're running really old hardware and you don't have DLSS turned on, and you're really missing out. It's a tech that a lot of people pushed back against in the early days because it kind of was a hot mess. It was noisy. It had all sorts of artifacts, and it was just not a great experience. Today, everyone on both sides of the fence, AMD fans and NVIDIA fans, I think can agree, whether we're talking about FSR or DLSS, it is an amazing technology because you can't truly tell the difference between the upscaled base resolution. So that's one thing I think you should hop on if you have pushed back against and haven't upgraded yet. That's a feature worth upgrading for, and that will make you more future ready when it comes to titles that are coming in the future, because guess what? They're all going to be like relying on DLSS to make the game playable, I think. It's just great features that have made developers a little more lazy when it comes to truly optimizing for the hardware. But if you want to truly be future-proofed, one, I hope you have deep pockets, because you're going to be upgrading every 2 to 3 years now because of how feature sets are popping up and how often you're getting gated behind hardware walls to be able to implement these newer feature sets. You're going to definitely have to overspec your power supply, because I don't think, like, we would all love to hear, let's just use NVIDIA as an example because they are dominating the GPU space when it comes to gaming, AI stuff on the side. When it comes to gaming graphics cards, they are just dominating and having the most cards available and the highest performance that you can buy if you have very, very deep pockets. I don't expect NVIDIA with the 6000 series to go, we've kept the same performance at 40% more power efficient. I'm just not expecting that to be the case. I'm just not. That used to be the argument. Remember, performance per watt used to be something people were super excited about. Now let's be fair. Us gamers really push back against it when a brand goes, look at the performance per watt. Because as much as we like to get up in arms, we also are all kind of, we're arrogant, and we like to say, but show me the performance. And if the performance is the same at lesser watts, gamers go, oh, that's not an upgrade. So let's be honest. Let's be real with ourselves. We as gamers are very difficult to please, especially PC enthusiasts. So we've got to take responsibility for that as well. And especially if we've been loud enough to say, no one cares about performance per watt. We just want the performance. and then they start giving you the performance at incredibly inefficient values, we can't then be like, but look at the power draw. Like, you can't have it both ways, guys, right? Let's just be honest. It's hard to be introspective at our own biases and such, but I think most PC enthusiasts would probably say, I want the performance over the efficiency. And that's the reality there. But to truly be future ready, especially with so many titles right now that have a lot of unknowns around them, it's probably a real 2 to 3 year upgrade cycle at this point. And that is expensive and very difficult to keep up with. Your case, it's just a box that holds your stuff that air can flow through, right? But let's talk about things like BTF. If BTF becomes a future standard, I don't think it will be, but if it did, and you don't have a BTF case, now that's Back to Front or Back to the Future, whatever you want to call it, because they keep changing the name, or Project Zero from MSI, which is just where the plugs are on the back of the motherboard where they don't show it all. If you don't have a case that supports that and that somehow becomes the standard, which I highly doubt, then you're buying a new case. Now, when it comes to future-proofing, I think I've given you some examples of as to why calling anything future-proof is absolutely wrong and impossible. There's plenty of things that you can do to try and stay as future-proofed as possible. Like I already gave you my recommendation of, case and power supply are about the only two things that you could possibly be as future-ready as possible without being left out. But here's the hard truth. Future-proofing used to mean you buy the highest hardware that you can today, just to lower settings in the future to make it last as long as possible as it starts to age out. But the reality is today you buy high-end hardware and hope you don't get locked out behind, paywalls for feature sets. It's kind of like hardware DLC now. We've all been screwed by gaming developers. Now we're getting screwed by the hardware manufacturers. So sound off down below if you guys have built yourself a system that you thought was future-proofed and you got slapped right upside the face by reality striking that you absolutely were not because you got locked out of feature sets. Thanks for watching, guys. As always, we'll see you in the next one.